So this will be the first video to talk about solids of revolution, and these are our most common solids to deal with in AP Calculus. Um, and I'm going to kind of talk about how we sketch it for a little bit longer than I did with the volumes of known cross-sections, just because this is more common, and it tends to be a little bit harder to visualize what's happening. So I have the function 2 plus x cosine x, and the region is between that function and the x-axis from x equals -2 to x equals +2. And so here's the region that's being revolved around the x-axis. The easiest way to sketch this is to take the function and mirror it over what I'm revolving around. So if I'm revolving around the x-axis, I'm going to sketch or attempt to sketch a reflection of that. That for me is not bad. And then if I think about what happens with one point as I revolve, this point comes down, around, and I'm getting a circle. This point comes down, around. There's a solid kind of hiding my view, but I still get a circle, and I get kind of a doorknob-looking shape. If I then slice this anywhere, when I slice it, I get circles. So we're going to be dealing a lot with circles because we're revolving around lines. We get a lot of circles with this. So there's my shape. I'm now going to sketch one cross-section. So there's the circle. The center is my x-axis coming out at us. And then my radius is changing. So my radius is going to be a variable because I don't know what my radius is. It's constant, or it's not a constant, it's variable. Well, my radius is going from my x-axis until I hit the function. So my radius is the function here. So my radius is 2 plus x cosine of x. So then the area of one cross-section is going to be pi times the radius squared, or pi times the quantity 2 plus x cosine of x squared. But that's just one cross-section. I need to accumulate all of them. So I need to accumulate all of my areas of cross-sections. Remember that in calculus, integrals accumulate for us. And my x's are going from -2 to +2. And again, using my calculator for this, I get that my volume is 52.429. To kind of get a better sense of what this looks like. So here's my function, 2 plus x cosine of x. We're going from -2 to +2. Sorry, it's a little bit crooked there. When I rotate it around, there's the solid I'm getting. You can kind of see, zoom out a bit to see my full doorknob-looking shape. Where this is coming from is actually us taking RAM and then rotating each rectangle, revolving each rectangle around the axis, the x-axis. So here's if I had one rectangle, two rectangles, three rectangles. So as I get more and more rectangles, you'll see that I get closer and closer to what the smooth shape will look like. So less rectangles, it's rougher. More rectangles, I approach that smooth shape.